Assessment 1, review, or really the only assessment, lesson by lesson, so they can taste the assessment. So let's see what we got here. All right, let's find out some stuff. Let's see what we have for box that includes the table. Now, what is true with this table? I'm kind of okay with any partners in addition to 0 and its partner. But normally you go 1 above it, -1. Usually that works out, but sometimes it doesn't. So let's see. Let's put that in, in the middle. I'll put him in red. I'll put him in green. He's not important like that. What's the partner to 0 on this one? -2. That's the winner. All right. Is there a partner for 1? Yeah. No partner for 1. What's the next number above 0 that actually has a partner? Like a positive number that has a partner and a negative number. Say again. 2 has a partner. Okay. What's the partner to 2? Okay. The number below 0 that has a partner. -2. Okay. And its partner? -3. -3. Okay. Now, for those who could be thinking like, how do they even know this? They just punched it in. The only thing that would mess you up, someone do me a favor. Punch in y equals 1/2 x minus 2, and tell me what partner it gives for the 2, for the 0, the 2, and the 2. Something should be off here, because in order to type this in properly, I'll do it in red so it can stand out. You need a parenthesis around a fraction that is next door to a letter, or if ever there's a fraction that has 2 pieces. So. All right, so let's pause this thing here. Let me graph it while they're punching in the other thing. To graph it, 0, 2. This thing is called, write this down, y-intercept. This is an important thing. If ever you have the number for y and the number connected to it, the x is a 0, we call that a y-intercept. Intercept, think of that word as just meaning 0. So when I say y-intercept, think, that's weird. Think they gave you the number for y when the other number is 0. So y-intercept, why? Because it always winds up on the y-axis. In other words, this dot intersects. Like in football, you intercept, you come and take something off of the y. What are the 2 other numbers? I'll make you guys in red. Why make you guys in red? Sure, blue. Sure, blue. 2 comma -1, 2 comma -1. Do you know there's some kids, they find this very difficult, the whole putting the dots in. I don't know how the teacher said it. I don't know why it seems that way. You got to run before you can jump is what I used to say. You got to run before you can jump. Now, I don't know what some other teachers say, -2, -3. Where am I? Yeah, here you go. Now, here's true. To draw the picture, you actually only need 2 of the dots. The 0 and the top one, the 0 and the bottom. They have to form the same line. I do 3. I don't know why. Just because 2 is so short. I don't know. But you only really need 2. Once you get the line, I always want you to name it. This is y equals 1/2 x minus 2. Pause. Keep going. The table for y equals the 1/2 x without. Let me do it the way the calculator would read it. 1 over 2x is what the calculator would read if you didn't put it in parentheses. 1 over 2x minus 2. I wonder what the table is for that. I assume the 0 is still going to be the same guy because 0 just makes that disappear. Let's find out what the other guys are. 0. Does it have a number for 2? What's the pair for 2?
It's the same thing.
Do me a favor then. Punch this in. 1 divided by 2x. Then the minus 2. Somebody has to hit the left arrow, the gray arrow, the right gray arrow, to get from under the bottom of the fraction. Otherwise, they'll put the 2 minus 2 under there with it. Okay. So I'm wrong. Dang it. Why would it know? How would it know? Reminder on this ugly one here. The calculator doesn't help you if you can't get y alone. It won't get it alone for you. Where are you? reminder on that guy. Step 1, move to the other side. Anybody who's not the y. So I want to put 4x minus 6, same number, opposite sign. The 6 changes, leaving you the original 3y. Move and divide, move and divide. And again, while it's true they're introducing this here in Unit 5, you did this in, I assume, 7th grade, something like that, a long time ago. 4x minus 6 over 3. If you're doing it by hand, this one is a little tricky. If you're doing a calculator, you just plug it in and it will give you what you need. The other part is, if there are 2 pieces on the top of a fraction, you do have to put those into a parenthesis. All right, so that's all. Let me get a double. We're going to switch it over. Solve for y. If yours is already solved for y, then you don't have to. But if yours isn't, boom, move it over. The good news is here, the minute I move this 2x over, this guy's ready to go into the calculator. He needs to stand red, though. He's ready to go into the calculator. The blue guy, oh, shoot, they made them both easy. All right, blue guy, the minute you move the 4x over, this guy's ready to go into the calculator. Again, you're going to produce 3 tables to show me what I'm looking for, which is 1. They know how to use the calculators. 2, they know how to read the tables. So this guy here is going to be y equals minus 3 plus 4x. If you move the 4x over and keep it as minus, the whole thing is messed up. Essentially what you do is you're subtracting, or rather you're adding 4x to both sides. They cancel on this side, they show up on that side. Pause, put it into the table, please. When you produce your first table, it is true y1, y2, just like we did last time. The middle is going to be the star. The middle is the place where we find the solution. What does it mean where we find the solution? The middle row is going to be the row where it is the x that has 2 y's that are identical. They're exactly the same number. That's the solution. That's the answer to the system of equations. Then above it, put what comes directly above, directly below. That are whole numbers. In other words, no decimals anywhere. Whole numbers. Then I'll tell you what to do next. 3, 3, 25, and 17. Hopefully they see that. What's going into the blue? The same x, but now the y2. All right, put that in. 3, 2, 1, 9, 5, 1. You're going to use the red alone to draw a red line. I don't know how you're going to highlight it on yours to make it red. We'll figure out, maybe we'll label it Y1. You'll use the blue to turn in the picture for the blue. This is how I know, the blue and the red, that you have what you need. You just have a picture, kind of sketch, because maybe you hit the graph button on your calculator. Won't be able to give you credit for it because I'll need 3 dots like this. 3, 3, where are you? 3, 3, 3, 3. 2, 5, 2, 5. It is true, check me, only need 2 dots. Because your table has 3, go ahead and put in the third one. 1, 7, where are you? 1, 7. 1, 7. Connect the dots and somewhere label that. I will allow you to label it Y1. I know Y1 because he's here on this table. If you have 2 different colors, obviously you do the opposite. Here comes the blue. 3, 9, same thing. 3, 9, where are you? 3, 9, 3, 9. So yes, they are giving you credit for Unit 4 for doing something that you learned in junior high. 2, 5, the only thing in junior high, unless you guys use calculators. 2, 5. The big deal is, can you produce it on the calculator and on a graphic calculator? 1, 1. Anybody in this room who is a junior, 1, 1. You will be taking the SBAC in May. Part of the SBAC is the use of graphing calculators. Unfortunately for options, again for this guy, he'll be Y2. Put the equal sign. Oops. Fortunately for options in other public schools, the SBAC doesn't count again this year. It didn't count last year. where two parallel lines like this, there won't be any matches. You'll be going up and up and up. After you go up to positive 10, you go down to negative 10. If you don't see any matches, hit the graph button. If you hit the graph button and you see this, there's no solution. They'll never crisscross. The other version is, no, I'm still going to take your hand, Karen. There's an infinite number of solutions. In other words, if they're on top of each other, all of these will match. It'll be 3, 5, 5, 2, 5, 5, 1, 5, 5. They'll all match. All right. When it is greater than, you shade above. So here we go. Let's see. For the red, it's less than, I'm shading below. If you have two different color highlighters or something, it would be good to use it, but you don't have to. For the blue, where's the blue? It's above. I'm going to pause here for a moment. Those are all the possible solutions there. There are an infinite number of solutions. They have to be in the shaded area. Let's go. We'll come back to you once you hear someone else that might make you guys go like, oh yeah. Back to one of the three. -2, -1 will do. Back table here. -4, -5. All right, you're down here somewhere. There you are down there. So when I grade this one, basically I'm gonna have to, there's no answer because anybody can put anything that they want that kind of fits there. Front table. -3, -3. Basically, two negatives will do, even though -1, -1, there's a problem. Oh, I'll put that for the person who wanted -1, -1, and I'll put a question mark as to why that one can't work. Hey, last table. Wait a second. You guys got out of it. You said it. Did you all say an answer?
-4,
-4, -2. All right, that works. All right, anybody then? Hey, answer to the middle one. He says no. Why do you say no? Oh, nah. Yeah. He's correct. Yeah. Now here's what's true. To be on a dotted line is a way of saying we're not including you. It's everybody like below us, but not including us. Okay. So no, because it's on dotted line. Okay. You're not part of the solution set. You're not part of the cool gang. Yeah, you're at the party. You're in charge of the door, who you let in and who you don't let in. Dotted line, you get to let people into the party. But can you come into the party? No, you can't. All night long, you're just at the door. On the outside of the door, that is. This solid line, you are part of the party. You're still at the door. You're at the boundary, which is what they call the boundary line of the answers. You're at the boundary. Let's see. Yeah, this guy here. How about -4, -0. -4, -0. Is he part of the solution? Yes. The solid line says yes, you're part of the solution. Yeah, you're at the door, but you're on the inside of the party. Things are going on. No, you can't come in. Okay, you're inside the thing. The dotted line, you're on the outside. You hear the music like, oh, can I come in? No, you stay outside. You're on the door. So dotted line, you're no, yes. He's part of the solution. Take a look at it for about 2 minutes.